In this lesson, we're going to be solving proportions and then doing some problem solving with proportions. So what are proportions? Proportions are when you have two ratios that are equal to each other. So here we see the first ratio is x to 4, and it is equal to 7 to 20. Because they are equal to each other, we can use a method called the butterfly method to solve this. The butterfly method means you look at the denominator of the first ratio and the numerator of the second, and you can look at the numerator of the first and the denominator of the second. So what I just created was I called butterfly wings, and each wing has numbers in it that you're going to multiply to set up an equation. So with this first wing, I had 4 times 7, and with the second wing, I had 20 times x. So we can set that up as an equation equal to each other. Here's my butterfly wings. So I got the 20x. Let me erase all this up here now again because it gets all too much stuff up there. The 20x I got from this butterfly wing, 20 times x, and we always write the coefficient in front of the variable. You could write x times 24, but that's just not the way we do it in math. We always write the number first, 20 times x. And for the other side of the equation, after the equal sign, I took the other butterfly wing, 7 times 4, or you could write 4 times 7. Because these are proportions, then these should be equal to each other, and now all you have to do is solve. To solve this, you go to the side without the variable first, and you do the multiplication, and 7 times 4 is 28. Now we have 20x equals 28, and to solve for our variable right here, we have to move what is attached to the variable. X is being multiplied by 20, so to solve for x, we have to divide both sides by 20, and 28 divided by 20 is 1 4/10. So we do something called the butterfly method, where the diagonals across equal each other, and we set up an equation. So let's try that again. Here we have b to 15 is equal to 66 to 99. So we know that this butterfly wing, 99b, is going to be equal to this wing, 15 times 66. Doesn't matter which side of the wing you write on the left side or the right side. I wrote the 99b on the left, but if you did the other wing first, like this, that's okay, because you're solving for b, and it doesn't matter which side the variable is on to start with, you're still going to be going through the same process. So I have 99b, which came from the first wing. I have 15 times 66, which came from the second wing. Now I go to the side without the variable first, because I can do the 15 times 66, and that is 990. Now in order to get b by itself, b is being multiplied by 99, so we're going to divide both sides by 99, and 990 divided by 99 is 10. So 10 would be the missing number in that ratio. So 10 to 15 is equal to 66 to 99. Try it again. Here's our wings. We could do our butterfly wings. We can 3 2/10 times 36 is going to be on one side of the equation, and 9n is going to be on the other side of the equation. So this time I put the variable on the right side, but it doesn't matter. You're always going to do the multiplication on the side without the variable first, and 36 times 3 2/10 is 115 2/10. Now to solve for the variable is being multiplied by 9, so we want to divide both sides by 9, and 115 2/10 divided by 9 is 12 8/10. So up here in our ratio, 3 2/10 to 9 is equal to 12 8/10 to 36. Again, let's try our butterfly wings. On one side, we're going to have 50 times 6 8/10. On the other side, we're going to have t times 34, or 34t. We're going to do our multiplication first. 50 times 6 8/10 is 340. Now to get the variable by itself, the variable is being multiplied by 34. So we're going to divide both sides by 34, and t is equal to 10. So 6 8/10 to 10, that ratio is equal to 34 to 50 ratio. Now let's try this with problem solving. We're going to have to set up the ratios based on what we read. An architect builds a model of a building before the actual building is built. The model is 8 inches tall, and the actual building will be 22 feet tall. The model is 20 inches wide. Find the width of the actual building. So we have the model of a building and we have the actual building. It says the model is 8 inches tall. The actual building will be 22 feet tall. The model is 20 inches wide. Why did I make that? That should be a much wider building. Let's redraw that. It should be more like this. 8 inches tall and 20 inches wide. Here is the actual building, which was 22 feet tall, but we don't know the width. So we want to set this up with a ratio. So we could take the smaller building here. We could put the height over the width, so that would be 8 inches to 20 inches. That ratio represents the model. When we set up the ratio for the building, since we put the height on the top, we have to put the height on the top of this ratio. So we would put the 22 feet on top, and we're solving for how wide it is. So the first ratio was the model. The second ratio was the building. Make sure that if you have height on top of the first, you have height on top of the second. Now we are ready to solve with our butterfly wings. So we would do 20 times 22 on one side, and the other side we have 8x. We would multiply 20 times 22 and divide by 8x. I'm going to erase all this because my PowerPoint's going to pull it up, but it really helps to draw pictures like that when you have story problems, problem solving. So here it was set up, and 22 times 20 is divided by 8 is 55 feet. So I didn't put this on the PowerPoint, but first we multiply 22 times 20. That would be 440, I believe. And then you divide that by 8, and that is 55 feet. Okay, let's look at another example. Mrs. Hidalgo paid $30 for 4 students to visit an art museum. Find the cost for 20 students. For our first ratio, we have $30 for 4 students. And we learned in our last lesson that when you're setting up a ratio that involves money, the money has to go on top. So we would set up $30 for 4 students. Now when we set up the second ratio, money is going to have to be on top, and the students is going to have to be on the bottom, just like we did with the first ratio. Find the cost for 20 students. So we know 20 goes on the bottom, and it's the cost that we're looking for. So we're looking for the top of the second ratio. So we do our butterfly wings. That would be 30 times 20 on one side, 4 times x on the other side. And now you would do 30 times 20, and 3 times 2 is 6, and you add your 2 zeros, so that would be 600. Set this up. So that would be 600 divided by 4, which is $150. The wait time to ride a roller coaster is 20 minutes when 160 people are in line. At this rate, how long is the wait when 220 people are in line? So let's look at the first bit of information. 20 minutes when 160 people. We set this up as a ratio. They said 20 minutes, so we'll put that on top. When 160 people, it helps to label it because you want to make sure that when you set up your second ratio, you have the minutes on top and the people on the bottom, just the way you did in the first ratio. Second bit of information. At this rate, how long would the wait time be when 220 people are in line? So we put that at the bottom of the second ratio. Here's the unknown number that we're solving for. So we set up, do our butterfly wings. We would have 220 times 20 on one side, and we would have 160 times x on the other. Then 220 times 20 would be 440. Erase that because it's going to be set up here. And then 440 divided by 160 would be 27.5 or 27 5/10 minutes. Alicia's class is making care packages for a local shelter. They can make 8 care packages with 240 food items. We're going to set this first up as a ratio. 8 care packages, so I'm going to put CP for care packages, 240 food items. So when we set up the second ratio, we want care packages on the top and food items on the bottom. How many care packages, so that's what we're looking for, can they make with 500 food items? So we set up our second ratio. We do our butterfly wings. So that would be 500 times 8. On the other side, we do the other butterfly wing, which is 240x. 500 times 8 is 5 times 8, which is 40. Then add your 2 zeros, so that would be 4,000 divided by 240. And that would be 16 2/3 care packages, or if you had a decimal, 16 and 6 repeating, which is 16 and 67 rounded to the nearest hundredth care packages that they can make. So this was proportions and problem solving with proportions.